The first thing you want to do when graphing a secant or cosecant function is write out everything you know that's going to impact your graph. So the first thing I notice is my A value right here. Typically when we're talking about sine or cosine, your A value is your amplitude. But because cosecant and secant aren't waves, we're going to think of that A value as giving you either your vertical stretch or your vertical shrink. So your vertical stretch or shrink depends on what that value is. Remember, if we're talking just positives, if it's between 0 and 1, that value in there, this is going to be a vertical shrink. And anything out here past 1, anything larger, that's going to be a vertical stretch. So in this case, some things I want to write down. This 1/2 for our A value, that means we're going to have a vertical shrink, and that's going to be by factor of 1/2. This 2, that's our B value, that's going to impact the period. So for this period, we're going to still, just like before, we're going to take 2 pi and divide it by B. So 2 pi divided by 2, that means our period in this case is going to be pi. And then plus pi over 4, that means that we are going to shift left pi over 4 units for our phase shift. There's no vertical shift, there's no reflection, so that's what we're going to start with. So we're going to start this because it's cosecant, that's very closely related to sine. I'm basically going to pretend like I'm graphing this function and that it has a sine here instead of a cosecant. So just like before, I'm going to draw my vertical axis and my horizontal. And since I'm going to go left pi over 4, I am going to make some room over here. But I'm going to go ahead and label my 4 tick marks, the 4th one with the period, and I'm going to have 2 tick marks up and down. Okay, so there was no vertical shift, so it doesn't shift anything up or down, so this is like 0. But our vertical shrink by a factor of 1/2 means I'm going to label this 1/2 and this negative 1/2, just like I would for an amplitude of 1/2. The period is pi, so I'm going to label this one pi. So half of that, here's pi over 2. Half of that, this one's pi over 4. So every tick mark is pi over 4. So 1 pi over 4, 2 pi over 4. So this is 3 pi over 4 and 4 pi over 4. Since I'm going left pi over 4, I am going to add a tick mark over here and label that negative pi over 4. Now, typically, when we're graphing this for a sine function, we would start on our midline and go up with our wave. So we're going to try that, but we're not going to actually connect our points. We're going to shift it left pi over 4. So you would start here and it would go up with your wave, back to the midline, down, and back to the midline. That would be if this were sine, right? But since it's cosecant, anything on the midline, when I take the reciprocal, it's going to turn into a vertical asymptote. So every of those points, every one that has a location on the midline, we turn into a vertical asymptote. Then the points off of it, we are going to keep, and we're going to create our parabola shapes. So this one goes up because it's above the midline. This one's going to go down because it's below the midline. And just like before, it's always important to check. So I'm going to check that one of our points works. So for example, I want to check that if I plug in pi over 2, that I get out the point negative 1/2. So if we plug this in, we have 1/2 times the cosecant of 2 times, in this case, pi over 2 plus pi over 4. So the first thing I need to do is in the parentheses, I need to combine these two fractions. So they need to have like denominators. So I'm going to multiply this one times 2 on top and on bottom, right? So pi over 2 is the same thing as, whoops, I went to multiply by 2. So this is 2 pi over 4, right? So 2 pi over 4 plus pi over 4, this is 3 pi over 4 times 2. So really that's 6 pi over 4 or 3 pi over 2. So really what we're doing is 1/2 times the cosecant of 3 pi over 2. So let's first talk about the cosecant of 3 pi over 2. 3 pi over 2 I know has a terminal point of 0, negative 1, right? So the sign is negative 1. Well, the reciprocal of negative 1 is going to give me negative 1. So the cosecant of 3 pi over 2 is negative 1. So 1/2 times negative 1 is negative 1/2. So that checks out. So this is a full period, right? One parabola opening up, one parabola opening down. So I have the completed graph. Let's try one more together. y equals -3 times the secant of 1/2 x plus 4. Again, we're going to write down everything that we know. So if this is my a value, the first thing that I notice is it's negative. So this is going to be a reflection over the x-axis. I also see that it's a 3, right? So this is going to be a vertical stretch by a factor of 3. The 1/2, that's our b value. So to find our period, we're going to take 2 pi and divide it by 1/2, which is the same as multiplying by 2 over 1. So our period should be 4 pi. The plus 4 at the end we know is a vertical shift. So it's going to move up 4 units. There's no phase shift in this case. So let's start it just like we would if this were a cosine graph, right? I'm going to draw my vertical axis and my horizontal. Because this is a vertical shift up 4, I'm going to label my midline 4. And what we're used to saying is our amplitude, but it's a vertical stretch of 3. So I'm going to go up 3. So 4 plus 3, this is 7. And then down 3, 4 minus 3, this is going to be a 1. And then I'm going to label my 4 tick marks. The 4th tick mark with the period. So the period is 4 pi. So each of these is going to be pi then. So pi, 2 pi, 3 pi. And I think I've taken care of everything. I just need to remember that there is a reflection. So if I were to graph this as a cosine function with a reflection, I would start down here at down here at 1, back to the midline, up, back to the midline, and below. So I'm going to utilize those. Anything on the midline now turns into a vertical asymptote, right? So we would have vertical asymptotes here at pi and 3 pi. Anything off, we keep that point, but it becomes part of our parabola that opens down. Anything off that's up, parabola opening up. And then same thing here, part of the parabola opening down. Now, you can draw in this side of that parabola and this side if you want, but you don't have to. This is considered to be a full period. If we want to check, just plug in a point. So for example, you could plug in 2 pi and make sure that you get out 7. So -3 times the secant of 1/2 times 2 pi, and then plus 4. So first we need to do half of 2 pi, which is pi. So we want the secant of pi. Well, pi has the terminal point. I'm going to write it over here, -1, 0. So your cosine is -1. The reciprocal of -1 is still -1. So the secant of pi is still -1. So we have -3 times -1 plus 4. -3 times -1 is 3, plus 4 is 7. It checks out.